Hello, Suffolk County Community College students. This is the second part mini tutorial on Python. So we learned the basics on Python and how to run in a notebook the Python code by doing Shift Enter, or in Google Colab you can just play this, click on play to run the coding cell. So we were since the last video right here at this point. We want to ultimately, with the focus of sciences, plot data, handle data, do math with data, get statistics from data. So to do data science. So in order to do that, so now that we know the basics of Python, let's insert some data. And how can you insert data? You can call X as a column, a list of numbers, right? 7, 15, 16. And there are little commands that are useful, say the length of the variable X, so meaning how many numbers there is inside of X. So 1, 2, 3, there are 7 numbers here, right? Inside of X. So say if I had put one more number here, 23, and I run, now X has 8 numbers in that line. So this is a list, right? We learned about that before, that if you start with the square brackets, and it is split, everything you enter there is separated by a comma. This is a list. And so a list is not as flexible to work in Python as arrays. So one of the greatest advantages of Python is to use arrays. And to convert a list into arrays, we're going to use this library called NumPy. So if it is the first time you're using a library, you import it. So you say import NumPy as NP. So I'm abbreviating the name NumPy to NP just to make life easier. So again, you're learning now, but Python step by step. But in the future, when you do anything in the future, you're going to put all these libraries, the math library, the NumPy library, all there at the top. You're going to call them all because you know they are useful and you want them all. Okay, so now I'm going to call a variable, X variable, as the array of X. So X was a list, right? Here created with square brackets. Now I want to transform, I want to call X var as the version of that list X as an array, because I know it'll be more convenient for me to work with an array. So once I have now that X transformed into an array, which is called X var, so now I can do mathematical operations with it. So for instance, I can say Y var is going to be 2 times X var. So every item inside the X var list array now will be multiplied by 2, and every value will be subtracted by 30. Okay. We can create zvar, which is, I'm using again this library called NumPy. Inside the NumPy library, again, you can do help NumPy, or actually it's going to be so large if you do help NumPy that it's better to go to another browser window and just say, and then Google NumPy. And then read, oh my God, there's going to be tons of tutorials there for you to, all the NumPy can do for you. And inside NumPy, there's a function called random, and then another subfunction from it called rand int. So what we are doing is we're creating an array with 39 random numbers, 39 because 39 random integers. Hold on a second. Why is this 39? This is not going to be necessarily 39. This is not 39. Sorry, dears. This is 7. Random integers. 1, 2, 3, 4, 5, 6, 7, right? So 7 because the size is 7. To be 39, okay, no problem. We can do 39 here. Can make this be size 39. It's such a huge thing. Run, 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 and run. This is the norm, 39 numbers, okay? So that's a teachable moment over here, because if I change this back again to say have just 5 numbers, so I want 5 random integers. Okay, I did this 5. You can see here when I'm printing, I have just changed the information about the z-var here, right? I wanted to have just 5 random integers. And here's where I'm printing the z-var. So why is it still with 39 numbers, right? Because I changed here for 5 from 39, and why didn't it update here? It will never automatically update. You got to think like a machine, think like a robot. You first need to, again, go from the top down to bring that new information down again. Wash that new information downward. So run this. Okay, and then run, and then run, and then run. Well, I could have run just this one. Now you see how it's updated and it has only 5 variables. So many times people coding or students will, discover, oh, there is a mistake down here. So I'm going to go up there where I made the mistake and correct it. And then they scroll down. Why didn't it change? Because I just corrected. Well, you have to rerun the code from the top. Run, 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 run. Bring that change down again. And then you see the update. Otherwise, you don't see the update. Okay. All right, so here we go. So as you can see, there's more flexibility when a variable is an array. And so we can now be organized and start listing. We can also handle this data even more by saying, for instance, I want to print only the 5th item, right? Only the 6th item actually in the xvar list. So what is the xvar list? Let's go to the xvar list. Here's the xvar list. What is the 6th item? This is 1, 2, 15 is 2, 3, 4, 5, 6. This 44 is the 6th item in the list. How do I print one specific item in a list? You can do like this. I want to print xvar, and then between the square brackets, I want the 6th. And why am I putting the value 5? So that's also an important basic thing about Python. Python starts counting from 0. 0 is always going to be the first order, the first number in counting items in a list, in an array. So if I need the 6th item, I will put the number 5, because you'll start counting as 0, 1, 2, 3, 4, 5, and 5 then will be number, right? Because I start from 0, it will be the 6th item in the list. Very important. Python starts counting from 0. Python starts counting in 0 with 0, okay? All right, so your turn. So there are the other data handling little things I am asking you to do. So you may not see, why do I need to do that in the future? As you're handling data many times, you have such a huge statistical table and etc. And I want just to know, what are the females here? What are the males here? Or I want to know just all the information after 2021 and all. So there are many reasons why you're going to want to select parts of a list. So sometimes there can be reasons why you would want to add two 1AD arrays, one-dimensional arrays, like two vertical, say, imagine in your mind 2 vertical arrays, into sort of a matrix, 2 by 2, or 2 columns, say. So how would you do that? Here's it's again one function inside the NumPy library called vstack. And the way you use it is doing np.vstack and then your two 1D arrays and then .t at the end. How would I know? This is how you could find that out. You would type on Google how to combine two 1D arrays, how to combine two arrays. And there'll be lots of suggestions there, and people will show you a line of code just saying np.vstack and then .t there. So you just copy, paste, try for your variables, adapt to customize to your variables, and voila. Next time you need again, do I need to memorize it? No, it's in a notebook somewhere. You're going to copy, paste, etc. You're going to Google again. That's how we do. Oh, you don't sit down to learn Python before you actually use Python. You go with the flow and you learn new things as you're using and trying. And as you need new things, you Google and you find and you cannibalize and bring it to your code. That's how you do. Okay? So now that we have this big array called XY array, I want to print the sixth, sorry, value in that X and Y var, which I printed here. So what is the six values? This row here, 4458, 4458, right? All right, and there are, as you go through the notebook, there are more things you can do to do selections. So for instance, if I want to now create a sub-array that is a selection of just some parts, I want just the parts of the array that have a value greater than 10, right? So I will create a selection of just values that are greater than 10 inside this array. You can hopefully see how this can be useful in data science when you're going to, that's all about data science, a lot about handling and selecting, no, I want just this, I want just that. Tell me what part of the data is doing just this effect, just that effect, right? So all those selections. So here there are little ways for you to handle and do some more selections. I'll leave these things for you to explore. All right, so this was just an X and Y initial X list that we inserted by hand, right? A few values that we inserted by hand. What if you want to insert actually values, huge columns of values from Excel, right? So one of the easiest ways to do that is use a package, a library called Pandas. Is the best one. There are alternatives, but the best one is called Pandas. So again, we're going to import Pandas as PD. Okay, so we want to call this Excel file. Okay, oops. We're going to call it an Excel file. I'm calling it. I could call something much easier. I could call it Excel, whatever, my file. I'm calling XLSX. And how you open this Excel or call this Excel file, you do this command, pd.excel file. Oh, how would I guess that? You will Google, how do I open Excel file in Python? And there will be many suggestions as using pandas. So that's why PD here is for that library that we called before, that we imported before pandas. So the trick here is to, put the right path. So you need to, if you're using a Google Drive, the path normally is content, drive, my drive, and then whatever's the name of the directory you put. For me, it was Python workshops, SCCC, da, 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 da. Okay, so you need to erase this and put whatever path you have. So, so now that we access that Excel data file, the data PyTutorial, we're going to read it. And we read it in a DF standing for data file. You can call it whatever you want, but it's easier to call it DF. So we're going to read that. So we are reading that Excel file call that I initially call XLSX. Okay. So I'm calling that as DF, my data file. So I want to print my data file, just to print the length of my data file. LEN is length. And it says it has 39 rows. 39 rows. So we are now going to actually print the actual file to see how it looks. So how can you do to print? Well, I call that file DF, data file now. So how do I print anything? Either I say print DF or I just say DF. So I just say DF and I am printing my data file. So that's how it looks here. It has 39 rows, and you may say, I know, but it says 38 here. Remember, it starts counting from 0. And, right, the first one is 0. 39 values, rows of values. And they are distributed in columns of time, position, error of time, and error of the position. Okay? The first row here is an invisible row. It's not a real. First column is an invisible column. It's not a real column. It's just an index. The column number 1 is really the time column. Column number 2 is the position. This is just an index that Python is using in the background. Okay, so it's good to see, good to know what it is. So if I wanted to print only, say, the 4th row, I will do df lock 3. Remember, you always use a number less than what you want there because start counting from 0. So that's one way. I want to print my data file, just the 4th row. And dot lock is one way for me to print all the, at that location, how it looks. So I got the 4 values of time, position, error of time, error of position for that 4th row. And there are more alternatives for selections here that you can learn, right? A whole zoo of selections here that you can learn. So go running those cells. And here we are teaching you how to create subsets of that big data file. For instance, here I am creating a subset called new set of data only for values that have a time greater than 35. So this is the syntax that you're going to use to do that type of selection. And then I'm printing the new set, and these are just the values. The rows that have values of time greater than 35 seconds. All right, so it's all about data handling here. Here I'm adding 50 to the position, to the value of the position. Every position here is been added 50, etc. And there's more things for you to play here, etc. So just as we did with the so just as we named the data inserted by hand as X, Y, and Z, it is convenient to name each column in the data file, in the DF. So here is us calling each one of the columns. So basically now we are turning each one of the columns in the DF file into arrays. So we are creating a time array, right? And we are using NumPy. Remember NumPy? We are using NumPy to transform that column in the data file DF into one array of time. And why we do that? Because then we can do this calculation. If we transform in arrays, we can do more calculations. We can plot. It will be easier. Okay. So yeah, this is where I'm going to stop with the details in this tutorial, because from now on, I'm going to just quickly browse through this notebook so that you can explore on your own as well. And those who are really interested should reach out to me to get to know more information, especially when we get to the part of plots. If you're stuck, if you have any questions and all, you can ask me then further. So tables, you can explore this on your own, but many times I inserted this part about tables, tutorial about tables, because many times when your students are writing a lab report or need to present something, they're seeing here the potential how Python can print things out, plots, well, you're still going to see the plots, but can print out details that can be used to attach to a report or something. And they can do that, Python can do that for tables. So here are just a few tutorials on how to make sort of nice tables with Python that you can then print and attach to a report. Some statistics. These are a lot of statistic packages that you use. So again, one of the biggest advantages of Python is that a lot of scientists use it. So they created a lot of support material, a lot of libraries and all, and you don't need to reinvent the wheel. And they're very powerful and they can pretty much do anything you want. So there are several cells here for you to take a look on how to get the mean, the median, the standard error, the mean, and etc. for a set of variables and other statistical parameters as well. We leave that for you to explore. The sort of second part of this Python tutorial, sometimes we do that in 2 days, not the whole day, but 2 afternoons, is the plotting part. That's what's very interesting for data science, for scientists, and etc. Perhaps you should have seen this cartoon from the beginning. I'm going to make it smaller here. Boy. Hold on a second. There you go. So this is a cartoon from XQCD. The author was a physicist once, and now he's an artist and is publishing books. And so the kid is here asking, "You're flying, how?" And he says, "Python," because he can do a lot of things. So plots. So now that you know and you inserted a big data set from, say, Excel, you want to plot that. So what do we use to plot? There are quite a few different libraries in Python to use to plot, but matplotlib is perhaps the one used the most. So we're going to import matplotlib and call PSPLT. So, so if you want to do a line plot, you're going to do PLT plot, and you're going to plot an X and Y variable. Here I'm defining my X variable using this command. You haven't seen that yet. It's inside the NumPy library called linspace. So generating a sample of X values. So you can always Google how to generate data sets, and there'll be many different commands, and this is one of them, linspace. All right, so we are plotting X versus X squared, and that's what we're getting here. So this plot, you can save this image as a PNG, whatever, right? And there's all the, in Google Colab, there's all these little tabs here that allow you to save the outcome, the product of what you're doing, of plots. We can make it better. We can put legends. We can put X and Y labels to this. We can use different colors. So here I'm using still PLT plot. And then there's an X and Y values. The Y value is this crazy functions, etc. So you can really play with that. What about a scatter plot, not a line plot? So I want to do a scatter plot of I want to do a scatter plot of the time and the position for that Excel spreadsheet that we got. So we're going to do a PLT scatter instead of a PLT plot. which will plot a line automatically. We'll do a PLT scatter. Scatter is just dots that are not connected. And this is the favorite type of plot that we ask in physics, that you don't connect the dots. Don't connect the dots. You're actually going to do a line of best fit or something like that, but you're not going to connect the dots. So scatter plots are favorite, say, in our classroom in physics. So you're doing that of time versus position, because you had defined actually several rows before we talked about tables and all. We had done this for time, for position, where we converted time from using NumPy, the time column in the DF data file, into an array, and it's called an array called time. So we can just plot now position versus time. They are arrays. Pose is an array and time is an array, and we can plot them. Okay. We can make it nicer. We can put grids. We can put titles. We can put labels, etc. That's more like what we would want. In physics, what's missing here now is we would want you to also do a line of best fit and tell us the equation of the line of best fit. So these are further steps that will be shown towards the end of this notebook that you're seeing here now. So as you keep scrolling down, you get there. What about pie charts? You may want to do a pie chart. The pie chart is plt.py. What are you plotting? There's just a sequence of values. It's not for a pie chart, you're not doing X and Y, right? You're just plotting a set of values. So here we are inserting a certain set of values here, random values, 5 random numbers between 1 and 50, and that's what we're plotting here. So every time you run the cell, it will be different because this is a random generator of 5 numbers. So every time you guys run this, or every time oops, now it's complaining because I had not run all the things from the top. See? I need to do this. Pum, 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 pum. Pum. Yep, it's complaining. The reason why it's complaining is because I stopped running everything. And because I stopped running everything from the top, it doesn't know anymore what to do, right? I was just talking to you and I was not running. So you are seeing already results from a previous run that was working, but I wasn't really running. So now I'm running and it's not complaining. And every time I run this cell here for pie charts, you're going to get a different pie chart because these are random numbers that we are having here. But that's how you do a pie chart. Bar chart, PLT bar. Again, what are you plotting in a bar chart? There is an X and Y values, right? There are X and Y values, so figure it out. Some of them can be just, instead of values, can be names, can be strings. So that's the example I'm showing here. So you learn from the examples, and then when you need to use, you copy and paste and slightly adapt this and that. If there's something that's not quite what you wanted and you still don't know how to do, you go online and you Google until you find it, and it's not hard to find. But that's the job. That's how you do it. Histograms. In science, we are often asked to do histograms, so it will be PLT hist. The thing about histograms is that you need to prepare the data before you plot a histogram. Okay, so you can read more about it. So as I say, here is your practice, is your turn to practice. So in that data pytutorial.xlsx, in that data file spreadsheet that you uploaded to your Google Drive, there are several tabs with data. So we were just playing with the data of position time for a car that's moving with, right, position versus time. But there is also one tab that has data for the students at Suffolk doing general studies, taking general education studies at Suffolk is the demographics of students, I think. STEM salaries in 2021 that you can use for a bar chart. There is another tab with data from Edwin Hubble from 1929, where he first saw the expansion of the universe. He plotted redshift versus the speed with which galaxies are moving away from us versus the distance the galaxies were from us. And we see that things that are closer to us are not moving away as fast, and things that are further away are moving away faster. And he interpreted that correctly as the universe is expanding. So that was the original data, which is wrong, by the way, very different from the value of the expansion of the universe we know nowadays, but the idea was totally correct. So this is the original 1929 data to make a scatter plot and get the so-called Hubble constant, the expansion of the universe constant. Again, the value that you're going to get is very different from the value nowadays, but it's the right idea. Data on COVID numbers at Suffolk for a certain up until 2021 or something like that. So that would be for a line plot. So now you would get an example, choose whatever attracts you the most, or if you're really wanting to learn, you would do all of them. So get that general education studies file and make a pie chart with it. Okay, and we're already calling that for you. That's going to be called DF2. So every time, so you go now to the top where you saw a pie chart, you're basically going to copy all that is about pie chart, where the pie chart was done. You're going to copy that code, bring it here. This is the space for you to do. I'm going to say make your plot here. So you're going to just copy and paste down there the code that you had before for the pie chart. And then you're going to adapt. What do you need to adapt? In the pie chart there, what were you plotting? You were plotting, there was one set of data. So take a look at either opening the Excel spreadsheet or just doing DF2. So say if I do like this, DF2, I gotta run this, and then I run this. So this is what the DF2 look like. So it is the race or ethnicity of students and the numbers that were in the general studies program at Suffolk at a certain year, a few years ago. So you're doing a pie chart of these races of or ethnicities, right? According to the numbers. So so now that you know that, you want to read the numbers that you want to plot are the second column of the DF2. So you should know how to select the second column of DF2 and put that to plot in the pie chart. So it is something you have to try on your own, and that's how you learn more. Okay. What if I want the Hubble data? What if I want to plot that as a scatter plot? So let's see the Hubble data. DF4, how does that look like? DF4. So there's an object, so these are galaxies. And then there's a position in megaparsecs, and there's the speed with which those things are receding from us, moving away from us in kilometers per second. So you're going to plot position versus velocity, say. So that's so the second column is your position and the third column is your velocity. So go back to where we had the scatter plot, figure out how to call in the DF4, because now it's not DF, it's DF4. That's where you're going to read the Hubble data. How to call the second and the third columns and plot them as at your X and Y. So practice with that and so on. And that's how you learn. That's how you learn. Here's some more statistics. Statistic never ends. Some more ways to do statistics. And ultimately in sciences, we want to fit lines or models to our data. We want to know if our data is a curve, if our data is a straight line, and things like that. So here we had that position versus time dots for the car data. That was called the data file, just called DF. And we plotted, we did we used a best fit algorithm and for a linear fit and a best fit algorithm for a quadratic fit. And the information is here, how you do that, all the code or how you call that. Now, which one is the best? Which one is the best? They seem to be similar. They're not equal. But which one is the best? And those are answers that here it's really not easy to figure out. So how would you decide? You then have another statistical test called reduce chi-square to decide. So basically, it's a residual value that you're getting between the fit and the each data point. So you are trying to find the fit that minimizes that residual, and that will be the best fit. So should this really be a linear fit or should this be a slightly curved quadratic fit? Which one is actually the best? Visually, you cannot judge that. You need to do the statistics. And when we do the chi-square fit, the linear fit has a chi-square of 3.6 and the quadratic has a chi-square of 3.2. So in principle, the quadratic is best because it has the smallest chi-square, reduced chi-square. So the smaller, the better for the fit. Okay, and you can continue practicing with in sites called, for instance, the codecademy.com to learn Python, and many things in there are free. You don't need to pay for all of that. So in this very brief tutorial here, we had some experience with some of the basic, more core libraries in Python, such as pandas, such as matplotlib and NumPy, right? So these are some of the core libraries, say, of Python. And then there is more. There's a whole universe of things that can be done. But yeah, that was the goal. And hopefully this will make you interested and will make you explore more and learn more. This is going to be useful in your future. I promise. Take care, guys.